Hi everyone, thank you for coming, and today I will share with you how we created our design system, Cosmos. And before start, I want to introduce myself. My name is Artem, I am Android developer at Badu, and I'm here responsible for design system. But if you don't know what is Badu, Badu is dating app, and where you can meet and date with other people, and we are available on all platforms, in Android, in iOS, in mobile web, and desktop web. And over the years, we created many others dating apps, such as Bumble, Lumin, Chapter. And to show how big we are, we have more than 1.5 billion users across all brands. But today, I'm going to present how we created our design system, but I wanted to start why we decided to create it, how we migrated to it, and also I talk a little bit about our internal tooling, and at the end of my presentation I will show you how it sped up our development, future development. But before, I want to say that all of us, we wanted to reuse UI components. And how we did usually, so designers just sent us designs, developer tried to split this design by UI components, try to find these components in the library, and if he can't find it, he just create new one to use it in future. But we had a problem with this process, and the problem was that we didn't have rules how to create new components. We didn't have any naming conventions, we didn't have agreement with designers, and sometimes it was impossible to find component in a library. And also sometimes we added some business logic in the UI layer. For example, we added sending analytics event, or even we tried to open internet connections. And the huge problem was also that sometimes we received designs with similar components. They looked similar, but developer can't understand, is it the same component, or designers wanted to introduce new one. And because of these reasons, our library were growing, and we really can't understand what we can use from here. But let's talk about our team. We had many actors who worked on UI. We have big team mobile engineers, big team front-end engineers, and big team of designers. And because of big size, the problem were big for us, and we found a lot of duplicated views, components, and we really can't reuse them. And as usual, product company, we had many redesigns where we think a lot, and because of it, in our code base we had 2 generations of components for old design, for new design, and it was really pain. And we figure out that it's much easier to just create a new component from scratch rather than reuse what we already had. I can show you a small example to highlight the problem. So we use a Simply. In Simply, designers send us designs. It's a web tool, and imagine we wanted to implement just simple text from here, and we saw that this text had a P2 size style, but we tried to find it in our code base, and we didn't have it. Okay, it's not a problem probably. Let's try to find it by text size. And we tried to find proper text size, and we had only 16 or 14, and it really was a mess. We didn't know what we had to do if we create with 15. So, but probably we hadn't do it because it's like an accidental movement. And for developers, it was really pain what he had to pick. And if we return back to all our problems, first we had somehow to solve, because it mostly problems in the one team, in the team of developers. So we can probably create the rules, create a separate model, or somehow, but yes, it's problem in one team. But with last point, it's very difficult because here we try to contact with different team, with team of designers. And to efficiently communicate with them, we had to create a set of strong guidelines. And as the set of strong guidelines, we decided to use design system. And let's talk about design system in general, what it is. So basically, it's a set of rules, UI rules and patterns, which are used in your product. And all these rules and patterns are documented somewhere in the wiki page and website, but the idea is these rules should be documented. And on top of this documentation, each team of designers, team of developers, doesn't matter, Android, iOS, mobile web, desktop web, they follow these principles and create own library. And of course, we have to set up a processes which keep all UI libraries are in sync. And this is in general design system. The main idea that it's more than it's a component library in the whole company. And we followed these principles in our design system, and our design system has name of Cosmos. And it's based on atomic design. It's like a simple conception. The idea is each complex component consists from more simple atomic components. And how it works, let's see in a small and simple example. Imagine you opened our application and you see profile. And here you can see Instagram section. In our design system, we have a component which has a name view profile block. It is responsible for showing some profile section. This component has a header, and also it has a content where you can add whatever you want. Here, for example, we added a list of items. For list, responsible scroll list element, where you can add items with user photos. And each item of user photo can be also in different states. For example, it can be in state showing photo. For example, we want to show also loading state. We want to show error. And for all of the states, we also have a responsible component. It has name user card. And also we have a button. And in button we have icon. Also we have a text, typography element, and all these components and others we have in our website. It is like a documentation. It describes all our components, their API, how they connected from to each other. And at total, we have more than 70 components which are covering many screens. And designers have the same library, iOS team has. And let's talk about Android team. But before start, I want to show you a small diagram. So we created first version of mobile app on 2009, but we migrated on our design system only in 2018. So we didn't have for 9 years any rules. We had this problem which I mentioned before, and as a result, to migrate, we had a lot of challenges. We had to fix problems with many generation of legacy styles. We had to support fonts. We had to avoid and somehow to fix our copy pasting in our components. And finally, we had to define the rules, how to create new one to avoid all these problems. And stage 0, global refactor. I can show you in a small example. It's how we worked with text styles. We had own styles, and we had to migrate to new ones. And because application was on production, we expected that it will be just simple mapping. Probably we will add some styles, just fonts. But in real life, it was like this because for some reason our library was shorter than designer's one. But also, when we refactored it, we found that it was like this because of we always override something, and it was really pain. But finally, after many steps of refactoring, we supported text styles, buttons, we supported really basic components, which we had on all screens. But also, we wanted to support layouts, because if we take a look on our application, what we can see that there are a lot of similar layouting patterns. For example, in our design system, we have a component which has a name city box with just a slot with just a container with 5 slots and with fixed margin between each slot. You can see we can put in each slot whatever we want, but idea is we can put any elements from our design system. And if you take a look on many other screens, we can see that almost all of them follow these principles. And also we wanted to support it, of course. And also we wanted to support atomicity, that more complex components consist from more simple atoms. And we had to improve our tooling and UI framework. What we did that for each component in our design system, we added a model, a mutable model which just describes its state. For example, for text component, we have text model in which we have a text string, text style, text color, and probably other properties, and they describe the state of view. You can see the code of model on the slide and how it works. The text component just has to implement bind method where he can receive this model, and here in this method just render state or render model. And also we have a utility class which has a name component controller. He just has a link inside itself to the other component from our design system. We can pass it when we create this component controller. And component controller also can work with models. He consumes this model, and when he consumes, he asks to component, hey guy, do you support this type of model? And if it's true, he just call in component bind method. And so it's like the same, like if we directly will pass to component model. But if no, if component A answers no, I don't support this type, controller try to remove, and he removes components A from view hierarchy and try to find the proper component who can handle this model. And when he finds it, he just inflate and finally pass. The idea is, you see, if we pass new model, it just, and the component can't work with it, controller will replace it. And we also have utility class, which always says, oh, I don't support any type of model, I want to be replaced. And if we return back to CTA box model, it has like property other components model. So it's just a nested class where we can pass whatever we want related, which has a implement component model interface. And XML file of this guy is for each slot we have component view stuff, which I already said. It's a guy who always wants to be replaced. But the idea is, by component view stuffs, we try to define layouting patterns. They have some strict rules where each view stuff be on the screen, which margin do we have for each component view stuff. And for example, to show this element, we create a model with, in each slot we pass model for each component, and we pass this complex model to CTBox component, and in the first tab, in the first stage, we have component use tab always in each slot, and each slot will be replaced by proper model or by proper components from our design system. And in this case, we will show this screen. And so if we want to just support atomicity, we just put component view tab in any place and use component controller and pass to it model. In this case, the proper view will be inflated dynamically. And when we created our framework, defined the rules, we wanted to increase the amount of components in our code base. But we had a problem because we didn't have a dedicated AI team who had to create all components. And all Android team was responsible for it. We had to create it. And let's look at the screen. Imagine developer will receive the screen. And for example, on top of the screen, we have just small cross, but according to our design system, it's a navigation bar. But imagine how many states navigation bar has. It can shows logo, it can have other icons on the right side, on the left side, also buttons on the right side. So also an image with name, with online status. So even also search. So it looks like a super complex component. And we can save the same rule for all components which we have in the screen if we didn't have them in our code base. And to create them from scratch, it will take many time because the components are really difficult. And we have an old approach. Why not? We can use image view. Why we need to create this complex stuff? And it will take like one day, And of course, the second variant is better. Before we didn't, like already said, dedicated team, and nobody wanted to implement it. But we tried to do by a new way. We tried to do it lazily. For example, in this case, why I have to implement whole navigation bar if I need only one cross? I just implement navigation bar with only cross. That's it. I don't want to implement search and other functionality. And we agreed to go by this way. It will help us. It helped us because we started to create new components. They was reused because somebody already created a simple version of navigation bar. In this particular case, the other guy wanted, for example, search. He just can find the navigation bar on our code base. Okay, he will check it, check that right now we don't support search. He implements search, and we have a toolbar, a navigation bar with cross and with search. But we have a problem because in this case, we'll often modify components, and since the moment when they are used everywhere, it's super high risk to break application. And to solve this problem, we introduced in our company visual regression testing. So the idea is quite simple. For example, one guy wanted to implement a component, for example, like circle image with badge on the right side. And he implemented this. For him, it's fine. He created test for it and store baseline. Other guy wanted to, for example, implement square shape of this circle image, and he implemented it, ran the test, and accidentally he broke somehow page position. Now it's on the left side. He ran test, and what he see that, test said that you broke something, please fix it. And we implemented this thing, and we implemented it together with our gallery, because the test case for visual snapshot regression testing is like the same what we can see in gallery. We just generated the gallery, and on top of it, we generated test cases. And since this moment, we can be sure that our UI component is safe. We can easily modify them, and we can be sure that we don't break anything. Since the moment when the amount of components are growing, we started to think that this amount of this library was on iOS, on Android mobile web, and imagine if designers wanted to ask, oh, let's change the color, and we had to do the same stuff in all platforms, or if they wanted to ask, let's change the corner radius or button, we had to do on all platforms. And also, we had interesting situation with assets. We had many quite similar, but in our code base, it was different assets. So, for example, Instagram, we had vector and like PNG. For picture with photo, it looks similar, but also it was two different files with Smile. And in the same moment, well, product management team and designers also wanted to little bit refactor visual identity of our app. What they wanted to update text styles. They also wanted to update colors. And also they wanted to update icons. And we sit down and found that if we somehow can create a tool which in all platform will send all icons, all UI configuration, we can define all colors and UI components by configuration somehow, and send this configuration and assets to all platforms. And if we will use it, problem related with redesign will be solved, because we just receive new config and automatically UI identity will be changed. And also we can support by this thing consistency problem. If designers wanted to update something, we just run the script with new version. And in theory of design system, they have tokens. It's like the same like UI configuration, basically just key value pairs. Let's try to find tokens on here. We have a button on the screen, and let's define any parameters here. So button has corner radius. It also has a text style with many other parameters like text size, text font, line height. It also has an icon, and icon has size. And total, we have 5 different parameters. And let's use probably like convenient format for it, and sit down with designers and ask them which parameters can be changed in future, or what you want to fix in our components. And when they decide what we want to fix, we create a config. And when they created a config, we can receive this config and parse it somehow and use in our code base. And when we, in future, when we will create UI component, we will not only check API components which we have in documentation, not only look at designs, but also we will use these tokens, this config, to create components. And since this moment, when we start use tokens as parameters of UI components, it means that all UI components, new UI components, will be in consistency if designers want or products want to just update color or text size or whatever they want. They just send us new config. And we did it. And if you are interested, we have an article about it. You can check a link. And in Android side, we have a Gradle plugin in which we pass a version of tokens, and it download tokens. We an Android team receive it in XML file. We use XML file, like it's like a usual resources. For example, how we did our text style, we just link to these tokens. And in this moment, since this moment, we were sure that all our components are in consistency. But what about icons? In theory, it can be the same, that we can also somehow store all icons, assets from our application, and somehow download them and use. For example, we want to receive it in Android in vector drawable. And the single storage for icons, we decided to have a Sketch, because designers are using Sketch, and they prepared for us set of icons, this one Sketch file, and we just parse this Sketch file in first stage in intermediate format, and from this intermediate format we parse it again, and in Android we receive vector drawable. How it looks like, it's just usual vector drawable, but one important thing here, we use not just a hex color. Icon has information about context, and here we use resources which we are here we use the tokens which we are receiving from config. And also we have a comment that just don't touch the generated file. It's for us, for developers. And if you're also interested, you can check also link, and we had a huge article how we did it in all platforms, in Android, in iOS, in mobile web. And in theory, when we implemented it to implement redesign, what we had, we just run script with new version of assets, of icons, of tokens, and we received a new configuration. But of course, before we little bit refactored it and prepared our application, and our design was done. But I want to also share with you with small tip. In redesign, we had interesting task when the same color in all our code base in new screens looks differently. For example, here red carrot. In new design looked like a carol. And in old app, the same red carrot looked as pink. So you see here, it's like a branching logic, and when we receive a config and use them, we don't have any branching logic, and we can't do it somehow. But how we managed to do it? So we define it just base colors, which just colors without context, just generic red, generic pink, they don't have any information. But also we have a feature colors, which are just linked to base colors. And here feature colors has information about the feature where we have to use it. For example, here it's not a red carrot, it's a feature, it's color feature like to you. And the same here, it's not red carrot, it's a feature live. And in your app, in your configs, we have a transition, and we know that feature like to you in your app is pink, and feature live in new design is coral. And that's it. Yes, we just updated icons, but before we had to migrate from usual base colors to feature colors, and finally we supported redesign. And after this stage, what we did, we had all our UI elements, UI components, and all assets in sync because we use single storage, single source of truth in all platforms, in Android, iOS, mobile web. And also we supported redesign if designers in future want to do the same. We just ask them, prepare please mapping, prepare please configs, and we just will update version, and that's it. And on next stage, we started to think how to scale it. Because, like I already said, we Magic Lab, we have many other products. For example, Bundle, and these other products looks like differently. It's a new product, but if we take a look on the screen, both application has on the screen navigation bar, profile info with name and age. Also, they have typography. And what started to happen that in Badoo we had a design system with tokens, with icons, so it's a huge amount of elements. And in other brands we had just a components library without any synchronization. Android, iOS had different libraries. And what started to happen that Badoo Cosmos started to move, and we tried to unify components from Badoo to adapt them to specific for each brand identity. And this adoption was made by tokens, because all our elements, UI configs or UI components was based on configs. We just can define specific config, for example, for button, it can be radio, corner radius, alignment, some information about text, and we can just pass these configs for each brand. It can be different config. And we had more complex cases, so we also have layouts, and we can do the same. For example, here we can pass as config alignment of children. For example, for this city box, in middle screenshot, alignment can be moved to right, and on the left screenshot, it can be centered. And we implemented it, so we can change it at runtime, but we don't need it. And it helps us to just reuse the same elements, the same components, the same code base in different apps. According to the code base, it was the same elements, but only different styles. And what else it helps us? It helps us that imagine if the amount of shared and unified components are growing, we can create a whole screens, whole features which functionally do the same. How this photo uploader, all application have photo uploader, and in code base is the same photo uploader, but you see here we have different visual identity, different color, different buttons, different icons, different toolbars with also different colors. And when we implemented this feature, we didn't care about it because we used our design library, and the library has information about config, how it should look like in specific brand. And I think most benefit we received in chat, because all apps now use chat, and we had a lot of features in chat, and developers also just create the component, use proper tokens, and automatically for specific app we show chat in good UI for this application. And if just we wanted to implement new app, we just receive new config and visual identity will be different. And I think that's it from my side. And what I want to highlight that it was really a difficult journey. We started from a very difficult position, but after it we step-by-step improving our tools. Visual snapshot testing really helped us. Now we can be sure that all UI components are in safe, they do the same. And also we solved consistency problem. So it also helped us. Now we just to update something, we ask to update config, and we receive it in new config. And also the great big benefit, I think, that now we can create new features which we can reuse between different products, just to when we connected it to a specific application. And thank you. And if you have any question, I will be happy to answer. But also I want to add that we have a stand where you can also find me and Alexis. He is from iOS team. He did the same for iOS. You can ask him how we did it in iOS as well. Thank you.